Hello there. Today, we're going to pull back the curtain on something that's fundamental to programming, but, well, it's often invisible. We're talking about the runtime environment. It's the stage where our code stops being just text and actually comes to life. You know the feeling. You write your code, you hit that run button, and like magic, stuff happens. But have you ever really paused to wonder what's going on under the hood? Where does that code even go? What kind of world does it live in once it leaves your editor?
Because really, when you think about it, our code is just text. It's a bunch of instructions written in a file. And for those instructions to actually do anything, they need a special, structured place to execute. They need an environment.
And that special place? That's what we call the runtime environment. You can think of it as this whole system built by things like your compiler and the operating system that acts as the life support for your program. It manages everything: memory, variables, how functions are called, creating this orderly little world for your code to do its thing.
Now, to really wrap our heads around this, we're going to use an analogy for the rest of this explainer. I want you to think of the runtime environment as a theater. Your code isn't just a program, it's a performance. And this environment is the whole shebang: the stage, the backstage, the prop room, the entire venue.
So, with that in mind, let's take a tour of this theater. The most important part of any venue is its physical space, right? In the world of computing, that space is memory. And just like a real theater, this memory space is divided into 4 main regions.
And here it is. This is basically the blueprint for our theater. This layout is a classic concept in computer science. You can see it's broken up into a few distinct areas. We've got a space for the code, a spot for static data, and then these 2 dynamic areas that are always changing: the heap and the stack. Let's look at each one. First, let's talk about the parts of the show that are pretty much set in stone. The code area. That's your script. It's the sequence of instructions for the actors. It gets loaded in and it doesn't change. Then you have the static area. This is like the permanent stage set. It holds things like global variables, stuff that needs to be there for the entire performance. Okay, now for the action. Most of the really dynamic stuff in your program happens in 2 key areas. In our theater analogy, this is the difference between the super busy backstage area and the giant prop warehouse out back. So let's start with the stack. You can think of this as the actor's backstage. It's where they get ready right before they go on stage, and it's where they come back to right after their scene. The whole point of the backstage is to be highly organized and super efficient. When a function gets called, that's our actor taking the stage, a space for all its local variables is instantly created on the stack. We call this a stack frame. Then, as soon as the function is done and returns, that whole frame is immediately wiped away. It's incredibly fast, super efficient, and perfect for temporary things. And on the other hand, we have the heap. If the stack is the immediate, tidy backstage area, then the heap, well, the heap is the theater's enormous, sprawling prop warehouse. The warehouse is where you go when you need something that's going to stick around for a while. Any objects you create dynamically, with the new keyword in a lot of languages, they get stored here. They're like props that aren't tied to just one scene. It gives you a ton of power and flexibility, but unlike the self-cleaning backstage area, the warehouse can get really messy. It needs more deliberate management. So let's just put them side by side to make it super clear. The stack is fast, very organized, temporary, and managed automatically. The heap is a bit slower, way less organized, built for things that last a long time, and it needs some kind of cleanup crew. It's a quick change room versus a long-term storage unit. And that brings up a really important question. How do we clean up that massive prop warehouse? Well, in programming, we have a special cleanup crew for that. I mean, think about it. After a play has been running for months, the warehouse is going to be full of old props from scenes that aren't even in the show anymore. If you just leave them there, you're going to run out of space, right? In memory, this problem has a name. It's called fragmentation. The heap just gets cluttered with all these small, useless, leftover objects. And eventually, you might not be able to fit a new big object in there, even if you technically have enough free space in total. The clutter just gets in the way. And that's where our cleanup crew, the garbage collector, comes in. One of the most common strategies it uses is called mark and sweep. It's a really simple 2-step process. First, the system does a full inventory. It walks through the entire program and puts a little mark on every single object or prop that's still being used. Then, step 2, it sweeps through the entire warehouse and gets rid of anything that doesn't have a mark. Simple, but super effective. Okay, so we've toured the theater, we get the stage, the backstage, the warehouse. But why does any of this actually matter to us when we're writing code? Well, because understanding the venue helps us direct a much better performance. There's a well-known principle in programming that says programs spend 90% of their time executing just 10% of their code. That tiny fraction, usually some kind of loop or a function that's called over and over, its performance basically determines the performance of the entire program. And that performance is hugely influenced by this principle called locality. The idea is actually pretty simple. Computers are way, way faster when the data they need to work with is physically close together in memory. If you keep your related actors and props nearby, the show just runs smoother, with less time wasted fetching things from all over the theater. And this is where it all clicks. Understanding the difference between that fast, local backstage, the stack, and the slower, more distant warehouse, the heap, is absolutely crucial. It gives you the power to make smart decisions about where your data lives, so you can take full advantage of locality. When you start structuring your program with this in mind, maybe keeping temporary, frequently used data on the stack, you create code that just runs better. It's more efficient, it's faster, you're directing a tight, smooth, quick performance for your audience, your user. So, if there's one thing to take away from all this, it's this. This wasn't just a technical deep dive. It's about changing your perspective. By understanding the stage where your code performs, you go from being just a scriptwriter to being a true director. You get to shape not just what your code does, but how well it does it. Because at the end of the day, code isn't just abstract logic. It's a living, breathing performance with actors and props and a stage. And now you know that stage a little better. Thank you for tuning in.